The article that I did was Why Faces May Be Special, Evidence of the Inversion Effect in Chimpanzees by Lisa A. Parr, Tara Dove, and William D. Hopkins. So some background studies that led up to this experiment were Vermeer and Hamilton, who tested split-brain macaques and found that face recognition is primarily a right hemispheric function. Tominaga, who tested Japanese macaques and found that they showed a preference for looking at upright photos of monkeys rather than inverted ones. But the thing that you have to note with that study is that not all of the stimuli in the experiment were faces, and some were whole body poses. Further studies were Parr, Hopkins, and DeWall, who tested chimpanzees and found that they exhibit the inversion effect for viewing unfamiliar faces of their own species. Diamond and Carey, who found that faces are primarily recognized using configurational cues, so that's as a whole rather than individual aspects of a face, and that causes stimuli to become sensitive to different environmental cues, including inversion. And the last study was that Wright and Roberts found different species of monkeys only displayed the inversion effect for human faces, leading them to believe that it is because human faces are low spatial frequency stimuli. So they came up with a few hypotheses for this study, and the first was that chimpanzees will perform better overall on upright stimuli, and if the inversion effect is because of low spatial frequency, then it will only be found in human faces. If the inversion effect is because of social expertise, it will be found in chimpanzee faces as well as human faces. And if the inversion effect is a right hemispheric action and based on configurational cues, it will be seen in all faces, but not automobiles. So the experiment had 5 chimpanzees, 3 males and 2 females, as the subjects, and they were each shown photographs of human faces, chimpanzee faces, capuchin monkey faces, and automobiles, and the automobiles served as the control. So below you can see the 4 examples of the stimuli shown to them, and they were all black and white, and as much background was removed as possible. So the chimpanzees had to move the cursor on a computer screen in order to show their answers, and the results found that overall upright stimuli were discriminated significantly better than inverted stimuli in all categories. And upright chimpanzee and human faces showed significantly more correct identifications than when inverted, and capuchin monkeys and automobiles showed no significant differences. So this led them to believe that there was a possibility that there was a floor effect, but the only significant difference between overall performances was for human faces and automobiles. So this graph above shows the results, and the table below shows the total number of trials given to each subject and their results for each. So the results support the expertise effect, but do not support the hypothesis of low spatial frequency information, and that's because the inversion effect was shown for chimpanzees as well. They also do not support that the visual system is sensitive to facial stimuli in general. And this is because there is no inversion effect for capuchin monkeys. And results may be because species are more able to identify others who are close to them phylogenetically, and when faces are familiar, recognition becomes a left hemisphere activity rather than a right hemispheric activity. And of course, there's much argument as to which theory can apply to all.